previous videos, we discussed about the phases of matter. We talked about what is matter, what are the different phases of matter, what are the properties of solid, liquid, and gas. But do we know what phase change is? Phase change. Let's break this term first. Phase basically means a specific state or period, while change means something is moving from one thing to another or something is transitioning from one thing to another. When we combine these two meanings and relate it to chemistry, we can conclude that phase change is the transition of objects from one state to another. An example could be water turning into ice or water turning into water vapor. These are all phase transitions, phase changes. Let's take a look at this image. These are the three states which we discussed earlier. So when we're talking about phase change, it's a change or the object is in one of these phases and it's going to some other phase. A solid turning into liquid or a liquid turning into gas or a gas turning into a liquid. It can be any of these. Let's still take a look at another image to look at all the phase changes that are possible. These are all the different phase changes that can occur. When a solid turns into a gas, it's sublimation. When a gas turns into a liquid, that's condensation. So liquid to solid freezing, solid to liquid melting, liquid to gas evaporating, gas to solid deposition. These are the six processes or the six phase changes that can occur. Now, let's try to understand how all of these happen in regards to the particles in solid, liquid, or gas. What do the particle need to do to transition from one state to another? We all know that these three states are made up of molecules. We sh- so we'll just figure out how these molecules allow this phase change to occur. This is the structure of the particles in the three different states that we know: solid, liquid, and gas. In solid, the particles are packed together. They only vibrate, they do not move. In liquid, they have a lot more liberty to move around. In gas, they have a lot more. They can just freely move around in a huge space. They expand. Let's relate this understanding of ours to phase change. Now, for a solid to turn into a liquid, what needs to happen? The particles shouldn't be in a fixed structure. They should start moving and they should, the particles, the structure shouldn't be intact, right? Let's take a look at a GIF. This is a GIF of an ice melting. Over here, the ice is transitioning from a solid to a liquid. Now, what do we generally do? For when we want to make ice, we put water in the freezer. When the ice has been formed, until it's in the freezer, it's in solid state. Once you bring it outside and keep it on a table or something, after some time, it turns into a liquid. Why does it happen? To understand that, we need to talk about energy. We all know that everything needs energy. That means even the particles that make up these three states need energy. These, based on energy, we can say that solids have the least amount of energy because the particles only vibrate, and liquids have the second least, and gases have the highest amount of energy because they can move around very fast compared to solid or liquid. So, and how do the particles get energy? These particles get energy through increase in temperature. When temperature increases, there is more heat, and these particles absorb this heat and convert it into kinetic energy, which is known as energy of motion. So, when we provide an object with increased heat through temperature, they gain more kinetic energy, allowing them to move faster and transition from a solid to liquid or from a liquid to gas. Let's take a look at a video to better understand the movement of particles when temperature is increased. Over here we can see that right now it's a solid. When we start providing heat to it, the particles are starting to move around. They're moving away from each other. As more and more heat is provided, the temperature over here is increasing and the kinetic energy of the particles is also increasing. Which is why when you place an ice in a much warmer temperature on your table, instead of keeping it in the freezer, it starts melting. Because freezer's temperature is much low, while the outside room temperature is high. So when this transition occurs, the particles gain more energy and they start moving, which allows the solid water ice cube to turn into water. Now, in the image, there are six things. Three occur when we increase temperature, and those are melting, vaporization, and sublimation. Because in all these three, um, the object is transitioning from a state which has where the particles have less energy to a state where the particles have more energy, which happens when the particles are provided with kinetic energy. Now, you can say that sublimation, melting, and evaporation, or we can say and vaporization occur when we provide the particles with heat. Now, the three other things in this image, right? Condensation, freezing, and deposition. In all these three, it's a transition from a state where particles have more energy to to a state where particles have less energy or less freedom to move around. Let's take a look at a video. Over here, the particles are moving. When we provide with when we reduce the heat, we notice that the particles are starting to move much slower. Why does this happen? Because when we remove heat from particles, they don't have more, their energy is reducing. They don't have more energy to keep moving at that speed. So they start slowing down. At one point, when the energy is constant and the heat is constantly reduced, the particles start to settle down at the bottom and form a solid, which is what these particles are doing right now. Now, these particles are just vibrating because they are in solid state. Now, condensation, freezing, and deposition occur when heat is removed. when their kinetic energy is reduced. When their kinetic energy is reduced, these particles can no longer move at that speed. Their energy is removed, so they start coming closer to each other, which allows them to, if it's a gas, it becomes liquid, and then if the temperature is constantly still reducing, it will turn into a solid. So let's just write that down. Deposition, condensation, and freezing occur when the kinetic energy of the particles are reduced. Now, in this, we notice two things. No, normally over here, solid turns into a liquid and then it turns into a gas. Or if it's a gas, it turns into a solid liquid and turns into a gas. Turns into a solid. But over here, they skip a phase. Sometimes solids can directly turn into a gas, and gases can directly turn into a solid. Those two processes are sublimation and deposition. We don't need to know why this happens, but it does. It's all we need to know for now is that there are two cases in sublimation and deposition where they skip the liquid phase and solids directly turn into a gas and liquids directly turn into a solid. And that is all for this video. Thank you so much for watching. Subscribe to our channel and like the video.